Greetings. I hope that you're doing well. I hope that life is treating you well, and remember that you are a wonderful person. And I'm going to try to get you through chemistry. I know it's not an easy class, so I hope that these videos will help you understand the material better. And if you're still having troubles, I will be more than glad to help you after you've watched this and tried the practice problems. I'll be glad to sit down with you, so just ask me. But in today's video, I want to show you how to do what's called Lewis dot structures. These show the valence electrons in molecules, and it shows how atoms are bonded together. And that way we can figure out some of the characteristics based on whether they're covalent, ionic, or polar covalent bonds. So I want you to understand what are some of the symbols, we use, and how to understand how nature works on these molecules. Okay, so one of the things that we use are dots and X's, and these are for unbonded electrons. These are ones that are just on the atom, but they're not connecting them with anything else. So if I want to show that two atoms are bonded together by electrons, then I'm going to use a dash, and the dash stands for a pair. So when you ever see a dash, that means two electrons. Okay, so I want to show you how to do single atoms first. So nitrogen, if you'll remember, it is on the periodic table right here. And the way I can tell the valence electrons is I go up to the group number, the one that has the A. Don't use 15. Okay, so it's 5A, and so it has 5 valence electrons. And so I'm going to put those electrons surrounding this. I'm going to use the dot, and I'm going to imagine a box surrounding that atom. So on that box, I can have 2 maximum electrons on each side, a total of 8 valence electrons. So here I'm imagining my box, and I'm going to put 5 electrons. I want to write them single before I double them up. Now, it doesn't matter which side I put them on. For example, I need to pair up one side. So these, I can put them anywhere I want. I like this form, putting the pair of electrons either above or below, because once I do compounds, it makes it so much easier to picture the electrons in a compound. Okay, now let's take a look at boron. Boron is in group 3A, and so it has 3 valence electrons. So again, I'm going to put them single before I pair them up, and I only have 3 electrons, so I will not have anything that's paired. Okay, let's try some more examples. Let's do chlorine. Okay, so chlorine, it's number 17. I put that so you can locate it on the periodic table easier. Okay, so chlorine right here, and it is in group 7A. So I have 7 valence electrons, so I'm going to put 1, 2, 3, 4, and then I start pairing them up. 5, 6, 7. And again, I like to have any single ones, I like to have it on the horizontal plane. But this would be perfectly fine. Alright, let's try magnesium. Magnesium has 2 valence electrons, so I'm going to put 1 on either side. I do not want to put them both on one side, because they like to be single before you pair them up. Okay, let's try some more. Now, okay, what I want you to do is I want you to find these on the periodic table. I put the atomic numbers, and I want you to do it. I want you to try putting the valence electrons and then try drawing it. Do that, pause the video and do that, and then let's come back and check your answers. Okay, so sulfur has 6 valence electrons, and so I'm going to put this as my a Lewis dot structure. Okay, I have 5 valence electrons for arsenic, so same as nitrogen. If you'll notice, they're in the same group on the periodic table, so they should have the same Lewis dot structure. Carbon has 4, and so I'm not going to have any paired electrons. And then aluminum only has 3, and it's in the same group as boron, so they should have the same electron structure. Okay, now we're going to take a look at Lewis structures in compounds. So that means you're going to have more than one element bonded together. So here are some symbols that you need to know. One dash is a single bond, two dashes, double bond, so 2 plus 2 that make 4 electrons, and a triple bond has 6. Okay, so a line means the share of electrons being shared. Okay, so let's try some examples. Okay, so let's do methane. Methane gas, if you've ever smelled a stinky cow pasture, that is methane gas. Okay, so once we want to look at the number of valence electrons, how many valence electrons each element has. Carbon is in group 4A, so 4. Hydrogen has 1, and then there's 4 of those. So I'm going to add these up. So 4 from the carbon plus 4 times 1 from the hydrogens, so it gives me a total of 8 valence electrons. Okay, so let's pause here and get a few things down. Okay, so after I've found out how many valence electrons total, we're going to see which one's in the middle. Is it the carbon or the hydrogen? Well, it's going to be carbon because it is closer to the middle of the periodic table. Okay, so if I look for hydrogen and carbon, okay, carbon and hydrogen, carbon is closer to the middle. So whatever is closer to the middle goes in the middle of the compound. Okay, make sure that every atom has an octet. That means 8 valence electrons around it. However, hydrogen is an exception. It only needs 2 valence electrons. So just remember that. Don't forget this rule. Hydrogen only needs 2. Okay, so let's try that. So carbon is in the middle, and I will put the hydrogens on the outside. I have 4 of them, so I try to distribute them equally. Okay, next I need to bond them. I need to put a dash in between the carbon and the hydrogen for each of the hydrogens because they have to be bonded together. So you know that there are 2, 2, 2, and 2, so I have 8 valence electrons accounted for. How many total did I have? 8, and so this is fine. So let's see if everything has an octet. Well, carbon needs 8 around it. 2, 4, 6, 8. Hydrogen only needs 2, and there are 2. These 2 count for the carbon and for the hydrogen. Okay, let's try another one. Nitrogen and 3 hydrogens. This is ammonia. If you've ever used a window cleaner or cleaner, that ammonia smell, it's real strong. This is it. Okay, so nitrogen has 5, hydrogen has 1, and there's 3 hydrogens. Add those all together, I should have 8. Okay, I need to connect these. And now let's see how many valence electrons have I used up. 2, 4, 6. Okay, so I take away 6 from the bonds, and that leaves me 2 electrons. So where does it go? It cannot go on the hydrogens because hydrogen already is having 2 around it. So I'm going to stick these right here, these 2 electrons. I'm not going to put a dash because remember, this is for bonded atoms, this is for non-bonded. Okay, so I have 8 electrons accounted for, 2, 4, 6, 8. Does everything have an octet? Well, hydrogen has 2, 2, and 2. Nitrogen, does it have 8 around it? 2, 4, 6, 8. Yes, so that would be the correct. Okay, let's try another one. So here I have 3 hydrogens, a carbon, and a chlorine. They're all bonded together. Sometimes I will underline the element which is the one in the center. But I can tell that, look at my periodic table, I've got hydrogen up here, I have carbon, and then I have chlorine. Carbon is the one that's closest to the middle, so I put that in the middle. And then I just arrange these on the outside. Now if I put the chlorine over here and this hydrogen over here, that's fine. Does not matter where you put it. What matters is do you have them connected correctly. Okay, so now I have added all the electrons. I have 14. Okay, so now that I know how many I have to deal with, now let's bond everything. Okay, put single bonds. How many did I use up to bond? 2, 4, 6, 8. Okay, so if I take away 8 from this, I'm going to have 6 electrons. So where do I put them? Well, it can't go on the hydrogens. The carbon already has 8 around it, so I'm going to stick it on here. Usually you're going to put the single electrons, any that you have, put them on the outside atoms. Okay, so 1, 2, 3, 4, 5, 6. Okay, again, do I have 14 electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have my 14 electrons. Does everything have an octet? The carbon does. 2, 4, 6, 8. These are shared, so it counts for that also. 2, 4, 6, 8. So now that one is correct.